In exercise 3.9.4, we are asked to show that P, given by this expression here, is a PDF if the conditions on these parameters are satisfied. So alpha is between 0 and beta, and Q is between this fraction and 0. So what we can immediately observe is that these are densities of an exponential distribution, one with parameter alpha, one with parameter beta. So we can see it's some kind of mixture or linear combination of these two densities. The key takeaway is to never forget the defining properties of a PDF. And the key solving ingredient that we will need to for this exercise is to use the PDF of exponentials. And two properties that they have is that they are positive and decreasing. So let us start by recalling what are the defining properties of a PDF. So P is a PDF if 1, it integrates to it's positive, and 2, it integrates to 1. So we need that the integral of 0 to infinity of px dx is 1. So let us start with the second one, because it's easier. And in this case, we see that if we plug in what we know for px, that this is equal to q. I'm going to split the integrals immediately. Q alpha dx plus 1 minus q times the integral of beta e to the power minus beta x. And we know that this is 1 and this is 1 because these are the densities of an exponential distribution, as we said. So they are by definition a PDF. So this must integrate to 1. And therefore we get q plus 1 minus q, and this is equal to 1. Alright, so we have taken care of the second property. For the first property, we need to show that it is positive. How we do that is by also using the fact that the PDFs of the exponentials, so of this part alpha and beta, that they are decreasing and positive. So we will use these two parts. If we start by writing down the definition of P, then we have that this is the definition, and we know that this is bigger than q times alpha e to the power minus beta x, 1 minus q beta e to the power minus beta x. That's because the e to the power minus some constant x, it looks like this, so it's decreasing, and therefore if we plug in the value alpha here and beta here, we know that alpha is smaller than beta. So if alpha is smaller, then it must have been, so it could be that alpha is here and beta is here. Therefore this value is bigger than this one, and this inequality holds. We can write down what this is, and we can take out the e minus beta x, and what we obtain is q alpha plus 1 minus q beta, right? And we need to show that this is non-negative. So is this the case? Well, we know that this part is non-negative because, as we see in this graph, the exponential is by definition non-negative. And we can show that actually for this part, we have that, well, we know some conditions on alpha and beta, and also on q actually. So what we can do is write this out a bit differently. So this can be written as where we take out q, so we have this, and this is actually bigger than b minus alpha times beta over b minus alpha. And this holds, let me show it actually, this inequality holds because we assumed that this holds. We assumed that q was smaller than beta over b minus alpha. And if you write out what, so this is by assumption. And further, if we write out what this fraction, it's simply 0 because these cancel, right? So you have beta minus beta and this is 0. So we have shown that it's positive. And so it's proven that actually P is a proper PDF.